One creative example of using algorithms in a data-driven fashion relates to a project I've recently been involved in, or still am involved in, with the MBA office at the Sloan School. The MBA office every year needs to assign all incoming students to so-called core teams. Those are teams of 6 or 7 students that spend a lot of their time together, interact closely as they go through the core courses and work on different projects and assignments. Now, those teams are meant to somewhat represent the class. We wouldn't want, for example, a class that is 40% female and 60% male to have teams that are all female or all male, because that would not really be representative of the class, and that wouldn't give the students the exposure to their classmates that they ought to have as students at Sloan. So creating those teams is actually a very non-trivial task if you do it by hand. Why? Because we have an incoming class of 400, 450 students. Separating those into teams of size 6 or 7, there are a lot of possible options. Optimization can really help define objectives for what the teams should capture, and then actually do the job of assigning students to each team. At the same time, of course, optimization is only a tool that helps here. It is not a solution in and of itself. If one wants a more diverse student body, assigning students to teams in a better way won't resolve that issue. If one wants a more diverse student body, one needs to work on the student pipeline, one needs to work on admissions. Those questions really come first. Optimization can then improve. Optimization can make sure that we do not have teams that are really not representative of the student body. Student teams with, for example, no international student whatsoever, teams that are, in terms of gender, greatly imbalanced. These things we can fix with optimization, but the underlying issues, of course, come at the point where the class is already admitted. So, in a sense, algorithms can improve things, but they don't necessarily reflect the entire problem. In many cases, algorithms are used for one part of the problem, but the larger systemic question remains open. This idea of algorithms making a dent in a problem, but not solving larger systemic issues, is one that is prevalent in other settings as well. One example that also comes from ride-hailing relates to driver earnings on ride-hailing platforms. There's evidence that driver earnings on ride-hailing platforms is mostly tied to wider economic questions that really drive the driver's outside option, that really drive how much money would the driver be able to make if they were not driving on the platform, rather than the actual questions of how well is the platform operating, how well is the platform's dispatch working, how well is the platform's pricing working. Now, we can improve the dispatch, we can improve the pricing, and we can thereby maybe improve the platform's profitability and the rider's experience. But if we want to also improve the driver's earnings, for example, then we'll either need to address their outside earning options, which are really outside the purview of the platform, or we need to think a lot more deeply about the market structure of the ride-hailing platform in a way that ensures that those earnings would increase.